Hey everyone, my name is Sahil and in today's video, we will discuss covered conductors and their accessories. By the end of this video, you will understand what covered conductors are, their various sizes, and the key accessories that are mandatory for their performance. But why should you listen to us? At Axis, we've been manufacturing and supplying overhead line hardware such as covered conductor accessories to more than 100 countries and for more than 30 years. Our accessories are approved in more than 80 utilities across India, Africa, and the globe. So let's start with the basics. What are covered conductors? Covered conductors are quite similar to conventional overhead power cables, but they are wrapped in multiple layers of insulating material around the core conductor. This wrapping helps prevent accidental contact with other conductors or objects, such as tree branches. Unlike bare conductors, the core is not directly exposed to the environment. If you look at the cross-section of this conductor, you will see several layers. At the center is the aluminum conductor. It is usually made from Al59 or ACS. This is the part that carries the current. Around that, there is a semiconductive layer and a longitudinal water blocking layer. These layers prevent moisture from entering and keep the current path stable. The outer part includes one or more layers of cross-linked polyethylene, also called XLPE. These layers protect against sunlight, heat, and electrical tracking. The outermost jacket is UV and track resistant. This is what makes the cable survive in open air, near trees, or in polluted areas without breaking down. Because of this layered construction, covered conductors are safer, more reliable, and better suited for areas with vegetation, wildlife, or harsh weather. In simple words, they are used in electrical power transmission and distribution because they make power distribution and transmission lines more reliable, they help cut down power losses in utilities, and they have an insulation coating that protects against water ingress and sunlight. They keep animals and people safe from electrical shocks and reduce power cuts. These conductors come in different sizes like 55, 70, 100, 148 and 240 mm², based on the current carrying requirement and the mechanical load they handle. For example, 55 and 70 mm² conductors are common in rural lines. 100 mm² is used in moderate road lines or industrial feeders. 148 and 240 mm² are used in long span lines, high load areas, or near substations. Each conductor needs accessories that are compatible with the required electrical and mechanical performance. Without them, even the best conductor cannot perform at its optimum level. For example, a covered conductor may carry current well but still fail if it cannot handle the line tension. That happens when there is not enough mechanical support. Think of a covered conductor like a strong rope. Unless it is held at both ends and gripped properly, it cannot do its job. One wrong clamp or connector can cause serious damage. Next, let's understand the accessories. Firstly, the Preformed Alignment Tie. It is used to tie the covered conductor to the insulator. It holds the conductor in place without peeling off the insulation. You will see it installed where the line needs support but does not terminate. It is made from UV-resistant engineered polymer and is preferred over metal ties. Metal ties can press too hard and crack the insulation over time. In contrast, polymer ties spread the grip evenly and protect the insulation. They also perform well in the sun, rain, and high temperatures. This tie is designed to work with a wide range of conductor sizes from 55 to 240 mm². That's possible because it is designed to wrap around the conductor without needing to strip or modify it. The helical grip adjusts itself based on the diameter and holds firmly without stress points. It also works with both polymer and porcelain insulators. So whether you're building rural lines with lighter conductors or urban feeders with heavier ones, this tie adapts to your setup and holds the conductor securely in place. Secondly, the tension clamp. The tension clamp is used to anchor the covered conductor at the end of a line where the line changes direction. It holds the conductor under mechanical tension and prevents it from slipping or sagging. The body of the clamp is made from corrosion-resistant aluminum alloy, and the wedges are made from UV-stabilized engineering plastic. This design grips the conductor firmly without cutting or peeling the insulation layer. That is important because the bare metallic clamps can damage the outer covering, which increases the risk of failure. The clamp uses a self-adjusting wedge mechanism, as you can see here, and as the tension increases, the wedges tighten automatically. This helps to distribute the load evenly along the conductor length without causing pinch points. The wedge grip adjusts to the conductor diameter, and this allows one clamp design to handle different conductor sizes without changing its core structure. It is also quick to install and needs fewer tools for assembly. We have a detailed video on its installation, and the link is in the description. Thirdly, the suspension clamp. As we have already discussed, covered conductors have insulation layers of water-blocking material, XLPE insulation, and many other things. All of this makes the conductor stronger, but also bulkier than bare conductors. The suspension clamp holds this cable safely between two poles without crushing or damaging the outer layers. It uses a wide curved surface to grip the insulated cable. Therefore, even under windy conditions, the clamp supports the weight without cutting into the insulation. This makes suspension clamps ideal for covered conductors, especially in areas with long distances between supports or where sag control is important. If you're finding this video helpful, please subscribe to our channel for more insightful videos on electrical engineering. Fourthly, the insulation piercing connector. The IPC is used to join two conductors without removing their insulation. It creates a live connection by piercing through the outer XLPE layer and making direct contact with the inner conductor. This is possible because the connector has specially designed metal teeth that cut through the insulation without damaging the core. The IPC is a safer and faster way to make connections on site, especially with covered conductors that cannot be stripped easily. It also reduces the risk of human error and makes installation possible even in live systems. There are three main types of IPCs, each designed for a specific purpose. The first is covered to covered. This is used when you need to tap power from one covered conductor to another. It is common in network extensions or T connections. The second is bare to covered. This is useful when you're upgrading old lines. It connects an existing bare conductor to a newer covered one, helping extend or retrofit an existing system. The third is for earthing. This type is used during maintenance or installation when the conductor needs to be grounded. It ensures a safe discharge path without stripping the insulation. The fifth product is the arc protection device. This device is a safety component used in covered conductor systems. It is designed to protect the line and hardware from damage caused by electrical arcs, especially during faults or short circuits. These conductors have insulation, but it can still burn or melt if arcing occurs. The arc protection device blocks the arc from reaching the insulator or the conductor clamp. It acts like a shield, taking the impact and keeping the rest of the system safe. This device fits between the conductor and the insulator, absorbing heat and mechanical stress caused by faults. It is built from strong polymer materials and has a metal stud to redirect the fault currents safely. Sixthly, the midspan joint. The midspan joint connects two pieces of conductor along a straight run. It restores both mechanical strength and electrical continuity without disturbing the insulation system. Inside the joint is an aluminum sleeve that carries the current. Around it is an outer layer made of polymer or heat shrink material. This protects the joint from moisture, sunlight, and mechanical wear. It ensures that even after a cut or a fault, the line stays safe and fully operational. I hope you now have a clear idea about covered conductors and their accessories. Axis MVCC solutions are designed to perform across all standard conductor sizes from 55 to 240 mm². At Axis, we are proud of our contribution to rural electrification projects in more than 80 distribution companies across India, Africa, and the globe. Axis products were critical to the success of government schemes like SAUBHAGYA and the currently running RDSS as well, playing a key role in enhancing electrical infrastructure. If you found this video helpful, please give it a like and subscribe to our channel for more insightful content on electrical engineering.